Welcome to the Nokia SR Linux Learning Essentials video series brought to you by the Nokia Data Center Fabric Certification Program. This video explains a special type of access control list called capture filters to filter packets for further analysis. An ACL is a kind of filter with a set of ordered rules. When an ACL is applied to an interface, the system will check every incoming or outgoing packet on that interface against the set of rules. Match criteria are based on various protocol frame header fields. When the packet matches a rule, the associated action is executed. This action can be either accept or drop, which means the packet is blocked. Additionally, matching packets can also be logged for further analysis. There are some special access control lists that work only on control packets terminating on the router. They are called CPM filters. They are similar to regular ACLs, but can also rate limit these matching control packets. SR Linux also supports another type of ACL called the capture filters. They allow you to analyze matching packets in a similar way to the Linux TCP dump tool. In this video, we will only cover capture filters whose primary use case is troubleshooting. Like the CPM filter, only one IPv4 and one IPv6 capture filter is allowed. When configured, the capture filter is deployed simultaneously on all sub-interfaces. Filtered packets are copied to the control processing module for further analysis. The capture filter ACL works with the traffic monitoring tool, which offers a sort of TCP dump capability hosted on the CPM board. We will now see methods for implementing a capture filter in the Nokia My Learning Lab platform. The lab topology consists of a leaf and spine data center with two leaf routers connected to two spine routers. The network is already configured so that hosts connected to leaf 1 and leaf 2 can communicate with each other. BGP is used as the underlay routing protocol. A typical capture filter use case is to run the traffic monitoring tool and specify the match criteria. For example, to monitor traffic on leaf 2 and capture ping packets between host 10 and host 20. In such case, the SR Linux will automatically create a capture filter ACL entry at the ICMP match criteria. Alternatively, you can first manually configure a capture filter and define its entries with match criteria, then run the traffic monitoring tool without specifying filters. For example, we will configure a filter to capture a complete SSH client-server conversation that transits the leaf 2 router. Okay, let's explore the capture filter in our lab. First, we use the traffic monitoring tool to detect ping packets between host 10 and host 20. Let's go on leaf 2 and run the traffic monitor command. We will specify the ICMP protocol as match criteria. The command runs in the foreground, snooping traffic on all interfaces and looking for ICMP packets. Note that the T-sharp file is created under the TMP root temporary folder. This file will be deleted as soon as the traffic monitor tool is exited. Note that in this case, you do not need to enter the candidate mode and configure a capture filter because SR Linux should have created one automatically. Let's open a second SSH session on leaf 2 and verify the automatically configured ACL filter named capture. As a test, go on host 20 and ping host 10 to generate ICMP traffic. Back to leaf 2. It works. ICMP traffic is logged to the session and stored in the T-sharp temporary file. Now we want to capture a complete SSH client-server conversation transiting the leaf 2 router. The match criteria are complex and cannot be written in a single command line. We need to manually configure a capture filter ACL to be used by the tool. Let's configure entry 10 IPv4, filtering TCP packets with host 11 as the destination IP address. And for the SSH traffic, filtered packets are copied from traffic flows on all interfaces. Now let's configure entry 20 to handle the opposite direction filtering for TCP packets. With the host 11 node, but now as the source IP address. For SSH traffic only, and copy the filtered packets. Now that the capture filter is configured, let's run the traffic monitoring tool without any match criteria. As a test, go on host 20 and SSH to host 11. Have a look at the running traffic monitor tool on the Leaf 2 session. It works as well. That's it for SR Linux capture filters. Thanks for watching, and be sure to explore the rest of this video series to learn more. And when you're ready to practice what you've learned, my DCF Learning Labs provides comprehensive exercises with step-by-step instructions and solutions, all in one simple browser-based application.